First things first, congratulations.
Thank you very much.
I haven't seen the Nexus yet. Can you show that as well?
I will, yeah.
So show us what you won there. It's Google Nexus.
Yes, lovely, delighted.
And can you tell me why you won? What did you win?
Okay, so basically I put together this poster presentation on my work in my PhD studies. So I'm in the University of Limerick and I'm in my third year of my PhD. So I'm working with organic pharmaceutical compounds. So as we heard in the presentations earlier, the pharmaceutical industry is hugely important, especially here in Ireland. And I just started off here saying that approximately 40% of promising drug candidates fail to reach commercialisation. And that's just because of their poor water solubility. So basically when you take the drugs, they're slow to dissolve into your body and bloodstream and they're slow to work. So that's a significant problem in the pharmaceutical industry. So that's the basis behind my project, and I'm trying to overcome that by enhancing the dissolution rate of the drug. So basically I can try and enhance the dissolution rate by reducing the particle size, as this image shows here. So that's just giving a more exposed surface area. It's simply like putting sugar into tea and stirring it around, it dissolves quicker if you give it a stir, that kind of thing, increasing the surface area. So basically I use a method where I inject a drug solution into a water solution where it's poorly soluble, and this causes the drug to precipitate as tiny little particles, and then these have a tendency to grow, so I incorporate some growth inhibitors in there as well, which can bind to the surface and they can just stop more growth units from joining on, and that can just hinder the growth process. So I'm trying to maintain the small tiny little nanoparticles.
Right.
So basically then I just do some testing on those, some dissolution testing, as you can see in this graph here. So this is the dissolution rate enhancement of the as received material. So it's quite slow, it dissolves 20% in 1 hour, whereas this is my nanomaterial, dissolves 100% in about 10 minutes. So it's quite a significant difference, and that would give enhanced dissolution rate and bioavailability in the body and just lead to better drug performance, more or less. Yeah.
And how long were you working on this?
So I've just started my third year. Maybe in the first year I was kind of just setting up methods and working on a different drug. So I've been maybe a year and a half working on this particular drug and establishing the method. So I'm almost finished on this part of the project, and now I'm going to move on to another drug compound and try and repeat some of the work I did here and hopefully see some similar results.
So when would you think you'd be finished with this research?
It would probably be another 2 years, maybe. There's a lot still to do. So I've shown in this graph here that I can only stabilise my nanoparticles for about 10 minutes. So that means I need to dry them really fast before they have a chance to grow out of the nano size range. So the big part of the project at the moment is trying to extend this period that they are nanoparticles. So that would just give, so if it was on plant scale, it would give a better chance for them to isolate the nanoparticles while they're still nano. So there's a little bit more work involved.
Well, good luck to you, and
thank you very much.
congratulations.
Thanks a million. Thank you very much.